Okay, last time we managed to determine these two equations here in the red box. Okay, they come from the standard sine and cos trigonometric equations for mathematics. Okay, so y equals the radius times sine theta, x equals the radius times cos theta. Okay, so this length here is r cos theta. Okay, and this length here down this side is r sine theta. Okay, so now by using these two formulas, we can work out the x and y position or coordinates of the red point in relation to the center of the circle, which is the orange point. Okay, so basically let's start up Blitz Basic. Okay, where is it? Blitz Plus, there we go. Okay, and open a new window. Okay, just to show you this, we're going to do kind of what looks like a double buffering, which is setting the buffer to the back buffer, then flipping it. Okay, that's straightforward. We've done that before. But what I wanted to show you is kind of what looks like a radar. The how to trace out the circle, how to do one of the hands. Okay, so the one part of the line is going to stay in the same position, i.e. at the center of the circle, and the other end of the line is going to follow a circle. Okay, so it'll look kind of like one of those radars, those old style radars that you see in those 1950s, 1960s American war movies kind of thing. Okay, so first we need to set the graphics, and 640 across and 480 down, 16-bit color, window. Okay, so 16-bit color, 2 is for window. Okay, set buffer, back buffer. Okay, so everything's drawn to the back buffer. Okay, not directly onto the screen, but to the buffer that's about to be displayed on the screen. So remember, we need the flip command. Okay, so that's our setup, and our we don't need an initialization. We can just move on straight onto the main loop in this case. Okay, so the main loop, standard while not something or other, while not key down 1, so while the escape key is not pressed, wend, and it's a good idea to put end. Okay, so this is our while wend loop. Okay, so I'm going to put flip right here, so it's automatically going to flip. Move the back buffer to the front buffer so we get to see what the computer's displaying, and then I'm going to clear it, and it's going to flip it, clear it, flip it, clear it, flip it. So it's going to draw the line to the back buffer, it's going to flip it to the front buffer and draw it, and it's going to draw the next incrementation of the line and clear the screen, and then it's going to draw that to the front buffer, etc., etc. Basically like a flick book. Okay, so the formula, the command for line, if I press F1, is the line, and you can see down the bottom we need the X starting position and the Y starting position. So it will draw it from here, and I want it to start in the middle of the screen. So halfway down is half of 640 is 320, half of 480 is 240. Then I want a circle, and remember our trig circle, x equals r cos theta, y equals r sine theta. So I want to move it across by x and move it up by y from theta 0 to 360. Okay, so I want to move it across by x and up by y. Okay, so I'm going to need these two for the x2 and y2, or the endpoint. This is x1, y1, and this is x2, y2. Okay. Okay. So you can see that down here, x1, y1, x2, y2. So I need to draw it from the center of the circle. Okay, and first we do the x coordinate, so it's at 320 now. Then I need to add, and I want it of radius 100, so that's our hypotenuse or our radius, and then I want to multiply that by cos of the angle, and I'm just going to call it A for now. And then for the y position, remember the y coordinate goes up here. We just want the length of the y coordinate is r times sine theta, or sine of the angle, which I've actually called A in Blitz Plus because it doesn't have the theta symbol in Blitz Plus. Okay, so it starts out at 240. Okay, and I want to shift it across. Shift it up the screen or down the screen. It doesn't matter because cos and sine are cyclic functions. So I could put minus to shift it up the screen, but it doesn't matter. We can start down here. Might as well be consistent because sine oscillates between 1 and -1. It doesn't really matter, and so does cos. So it doesn't really matter where you start on the circle. So actually, I'm starting not here. I'm starting down where my mouse pointer is. Okay, but it's essentially it's the same thing. Okay, so sine A. Okay, so this is the center of our circle, 320, 240, and this draws a line to a point on the circle. Okay, now we need A to increase, so we go A equals A plus 1, and that will keep on increasing in the loop, and it will just keep on increasing. A equals 2, A equals 3, A equals 4, and it will substitute that. Obviously that is our A there. Once it gets to 360, it will just keep on going, 361, 362, 363. We don't need to worry about numbers above 360 because sine and cos are cyclic functions that just go on forever. They just keep oscillating, going up and down between 1 and -1. Okay, so kind of like if you draw them on a graph, they will go kind of up and down like a wave. Okay, they actually look like a wave. Okay, if you draw them on an XY graph, if you draw the angle across the bottom and the Y on the vertical axis, they actually sort of go up and down like a radio wave. Yeah, so they just go on forever. So you don't need to worry once it goes past 360. It just keeps on going and going and going. Okay, so if we run this program, then hopefully we should get our desired result of a hand like that of a hand of a clock going round in circles. And there we go. You can see our hand going round in a circle. Okay. Okay, and just to finish this off, we can use the command oval. Okay, and what oval does is it draws circles. Okay, so for the oval command, if I press F1 when I'm on there, it gives XY origin, width and height. You've got to remember the X and Y origin is not in the center of the circle, it's on the top left. So if I was to put 320, 240, and then I was to put the width and the height, obviously it would be double the radius. Okay, then I would get this result. Okay, you can see this is the point, the corner of where the circle or the square the circle is contained in is exactly this where we want our center to be. Okay, so we actually have to, we also want it to be hollow. Okay, like that, and that means we've got to minus the radius, I think. Yes, my calculations. So I've got a minus 100 off here, and I've got to minus 100 off here. Okay, and there we go. Now you can see we've kind of got a radar-like thing there. Okay, this is the end of this tutorial. I don't want to get too far ahead within one tutorial, just kind of take it one step at a time. Okay,